Hello everyone. So in our last video we discussed that our code is suffering from memory leak problem, and now in this video we will discuss the solution. And now let us start discussing the solution. So in this part and in this part we are deallocating the memory. We have to deallocate the memory, so we have to change only this part and this part. Okay, so first let us try to handle this part of our code. So if this is my linked list 1, 2, 3 and 4 and the value of I is 0, that means I want to delete the first node, the head node. Okay, so the proper way to delete is first isolate that node and then basically use the delete keyword. Okay, so first make the node isolate and then basically we will delete the node. Simple. So I want to delete this node and this node is basically head. So first step is basically store the address of the next node. If you will directly call delete head, okay, if you directly call delete head, then basically this memory will be deallocated, and similarly you will also lost the rest of the linked list. Why? Because the address will get lost of this node, because this node is storing the address, and as soon as you delete this node you do not have access to the second node. You do not know the address of the second node, and if you don't know the address of the second node, you do not know the address of this node. If you do not know the address of this node, you do not know the address of this node. So basically the first step is very simple. We have to store the address of the next node. Simple. Okay, so first step is store the address of the next node, and that next node, so this is the next node, this will be my new head. So I am taking a variable new head, and this is basically the next of head. Okay, so now I have one more pointer. The name of this is basically new head. Simple. Now what is the meaning of isolation? So this node is basically pointing towards this node. Okay, so ideally it should point towards null because we are going to delete this node. So what you have to do, update its next pointer. So head arrow next is null. Okay, so as soon as you do this, what will happen? Now 1 is pointing towards null, and we have 2, 3 and 4, and 2 is basically your new head. Okay, you have new head variable, right? So this is your new head, and 1 is pointing towards null. So this is the meaning of isolation. So this node is now isolated, and what you have to do now, we have to call the delete keyword. So we will write delete head. Okay, so delete head means deallocate the memory. So now this memory has been deallocated, and now what we have to do, so you can see we have to return the return type of the function is node star. So we have to return the new head. Okay, so I will return the new head, and this is our new head. Okay, so I will return the new head, and new head is basically this 2, 3 and 4. So this is my new head, and I will return the address of this node. Okay, simple. Now we do not have any memory leak problem and everything will work fine. Okay, so this node has been deleted from the memory. Okay, so we have to perform these 4 steps, and remember, if you want to delete the node, first isolate and then delete. So this is isolation step, this is delete step, and this is basically we have to do. Okay, there is no other option. You have to store the address of the next node because you are going to delete the current node. Simple. And after storing the node, here you are returning the node. So let's update this part of the code. So let's remove this. So first step, store the address of the next node because the current node is going to be deleted. Simple. Now isolation step. After isolation, delete step, and after deleting, the return type of the function is node star. So return the new head. Fine. So we have updated our this part of the code. Now the only thing remaining is this part of the code, not this one, this part. Okay, this part of the code. Now let's see how we can handle this part of the code. So this is my linked list 1, 2, 3 and 4, and let's say 5. Okay, so suppose this is my current pointer Now currently what we are doing, we are checking current exists in the next of current. Yes, 3 exist and 4 exist. True. So we will go inside the if part and we are doing this thing. And this this connection will be broken because we are doing the next of current is next of current. So what is the scenario? We have 1, then 2, then 3 and then 5. So we have this node 4 and this node 4 is pointing towards this node 5. So somehow we have to delete this node 4. Okay, now let's see how we can delete this node 4. Okay, so again we will follow the isolation step and the delete step. Isolate and delete. Okay, so how we can isolate this node? Okay, so according to me, let's name this node as temp. Okay, so node star temp. So what is temp? Temp is nothing, it is just the next of current. Okay, store the next node. Store the next node because we need address to delete a node. So I am storing the node because I want to delete that node. Okay, simple, fine. Then what you have to do? So we know the address of this node. Okay, then we have to write this thing. The next of current is basically, you can write temp arrow next, or you can write the next of current is basically next of current. Both are same. Both are, these two lines are same. Okay, you can see what is temp. Temp is nothing but current arrow next. So current arrow next is temp. So at this step what will happen? We are naming this node temp. Okay, now at this step we are making this connection. Now it's time to isolate this node. So for isolating the node, what I will write, temp arrow next is null. Temp arrow, so temp was pointing towards this node 5. Now after this step, temp is not pointing towards node 5. In fact, it is pointing towards a node null. Okay, so what is my linked list now? 1, 2, 3 and 5, and we have a node 4. It is pointing towards null. So this basically, the meaning of this is basically, this is your node, this is 4 and the next is null. Okay, so now this node has been isolated. So what we are waiting for? Just delete this node. So delete temp. Okay, this node is temp, so delete temp. So everything is logical. Okay, everything is logical. So let's write the code. So let's remove. Okay, we have to return head. We have to return head. So let's not remove that line. So we have to create a temporary pointer, and this is basically, or what you can do. So we need this line, right? Okay, but before, one thing here. So can you write this line before this line? My question is, can you write this line first and then this line? Basically, can you change the order? No, you cannot change the order. Why? Because if you will write this line first or this line, both are same, then you are making this connection and you will lose the access to this node. Okay, you will lose the address of this node. So these steps have to be performed in this order only. Okay, order is very important here. If you will perform this step first, then you cannot perform this step because you will lose the address of node 4. Okay, so order is very important. Do not change the order. So before doing this step, you have to do this step. So node star temp. So temp is the node that we are going to delete, and this is next of current. Okay, so store the address of the node which you want to delete. Now before deletion, let us isolate that node. So temp arrow next is null. So this is isolation step, and after isolation, just delete the node. So delete temp. And after deleting, the return type of the function is node star, so I am returning the head. Okay, so this is how we can solve our memory leak problem. Simple. Now let us try to test our code. So data is 1, 2, 3 and 4 minus 1. I want to delete the node present at index 3. So 1, 2, 3 and null. The node 4 is getting deleted. Let's say I want to delete, so first data 1, 2, 3, 4 and minus 1. I want to delete the node present at index 0, basically the first node. So this is my updated linked list, 2, 3, 4 and null. Okay, so that's how our code is working. Now everything else will remain same. So this is how we are able to avoid memory leak. Okay, isolation step, delete step, and I think we forgot to discuss the time complexity. So again, what is the time complexity? So I think this work is constant, this work is also constant, and this work is also constant, this is also constant. Now only this part. So time complexity is nothing but big of I, and again in the worst case it will be big of n. Okay, simple. So if you have any doubt in this part, in this question, in this logic, you can ask me in the comment section. And once again, do not change the order. Okay, the order is important. The order in which we are performing the steps is important. If you try to play with the order, you will get wrong answer. Okay, so I will see you in the next video. Bye bye.